So here we go with part 2 of the review. Here is that function I was looking at in the last, in the multiplied out form. And I just want to go over a few things about it again. So again, my hope was that you remembered that this is a quadratic function from Math 95. It's called quadratic because the highest power is a square right there. And some things to remember about quadratic functions. The most important point is the vertex, and we'll explore this again in chapter 2. So the second chapter is actually easier than the first because it's a review. Always comes from x equals negative b over 2a. And when we plugged in b equals negative 4 and a equals 1, we found that x was equal to 2. Now function notation is designed for substitution. So if I know that x is 2, f of blank is always blank squared minus 4 times blank plus 3, I can just plop that 2 in and do my arithmetic. 2 squared is 4, minus 4 times 2 is 8, 4 minus 8 is negative 4, plus 3 gives me negative 1. So like we saw earlier, the vertex is 2, negative 1. Consistent with the other version of the parabola that we were playing with in the first video. At least I was playing with. I hope you're playing too. What fun is math if you don't all play along, right? Remember, I'm the coach, you're supposed to practice. So just to double check that vertex with a wee bit of technology, I got my TI here. See if I can hold it in a way that doesn't glare on. Here's that parabola. And right now the calculator is telling me that there is a minimum of 2.000004. Its best estimate at the bottom of that parabola, x equals about 2, y is negative 1, which is what we have here. To have the calculator find that, you first have to enter it in. Now that is the shifted version that we were playing with earlier. I'll turn that one off and type in our new version. Different equation, but same graph. X squared minus 4x plus 3. And if I hit graph, I should see the same thing. If you're not sure what window to use, a good place to start is zoom. Oh, here's my cat. Say hi, Sal. Go away. Oh man, he's a heavy one. Okay, let's see. Zoom 6, zoom standard is the way to go, which is the screen I had before. I could trace and try and locate that number, but it traces weird values. All right, so that's kind of helpful, kind of not. I can see the minimum is somewhere near x is 1.9, y is negative 0.99. So what I want to do is go above trace, which is the calculate menu, second trace, and I want to have the calculator find the minimum value of this graph. So it says, give me a point to the left. So the left boundary is to the left of the minimum. Enter. Then the calculator says, find me a right boundary. Let's get a little to the right there. And then back in the middle for a guess. And the calculator does its best guess. Notice this time it told me negative or positive 1.9999985, which is pretty damn close to 2. Y is negative 1. So it usually nails the y, and the x is sometimes right and sometimes off. So we use our best guess to say, it's probably 2. Can't do the exact, but it can do approximations. Okay. So that's a nice use of the calculator. So we're just going to make a rough sketch of this graph here. I wish I had graph paper, but I forgot to get some out. So let's see, we know we have a minimum at 2, negative 1, right there. I could make a table of numbers to go along with this, and the calculator can help with that. One way I can do that is if I get into trace mode, I can just say, well, what if I type 1? When I type 1 in trace mode, it says, oh, you mean x is 1? If I hit enter, the calculator says, oh, okay, well then y is 0. So I know I have the point 1, 0. And I could say, well, what if x is 0, enter, y is 3. Okay, fine, smarty pants. What if x is 1/2, 1 over 2? Enter, y is 1.25. So I can generate a whole bunch of points quickly while looking at the graph, which is kind of nice. So here, now again, the 3 right here is the y-intercept. Hopefully you remember that from Math 95. So that's right there. I had the point 0, 1. I'm guessing due to the symmetry of a parabola, I'm going to have the point 3, 0. Let's double check. Calculator, type 3, and you got to be in trace mode for this to work. 3, enter, 3, 0, yep. And I'm guessing I have the point 4, 3, because the parabola has a line through the vertex called the axis of symmetry. We'll study that more in chapter 2. Again, it should be a review of stuff you saw in Math 95. So here's my best artistic rendering of this graph. I'm lacking some information, numbers. For example, that's y equals -1, 1, 2, and 3. You don't need to label every number, but you should label enough so that somebody else could look at this and know what they're looking at. X-axis, y-axis. Some things to note. I put arrows on each end indicating I believe it continues with a similar trend, right? Up and to the right a little bit, up and to the left a little bit. Some other things I'll note about this: there is a lowest point here. There seems to be a min for this function, f, and that min is -1, right? The minimum is -1. It happens when x is 2, but the minimum is -1, okay? So that leads me to believe that the range for this thing, y is greater than or equal to -1, or square bracket -1 to infinity. In this case, the infinity means up forever. Pretty nice, huh? Not a bad graph. Again, calculator is really helpful in making that happen. Graph paper is even better. Other things I'll note here. If we think for a moment about x as time, time always moves in a positive direction. We can't go back in time. Then this curve represents the path of an object moving along it, and it moves along the curve in this direction because that's the way I'm at. Like, this is 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, and so on. And if I consider time that way, then what I can establish is this, to the left of this minimum point there, the function is decreasing, and to the right, this side, I'm on an increasing part of the curve. And the whole increasing and decreasing only makes sense if you consider x as time and you're always moving from left to right for x. And then to describe to somebody when it's increasing, I would say it's increasing on a part of the domain. And the part of the domain it's increasing on is anything to the left forever, all the way up to x equals 2. It's decreasing. It's increasing if x is in the interval from 2 to infinity. Now at 2, at that point at the bottom, it's neither increasing and decreasing because we're dropping down. Then we kind of level out at that moment, and then we start to rise after that. So at 2, it's neither increasing nor decreasing. So there's never a square bracket when I'm talking about increasing and decreasing. Okay, so that's an important part of functional analysis. Function analysis. Functional analysis is a whole different thing. We don't want to go there. All right, let's see. Let's look at a more interesting function. How about, let's take that function we had earlier, 5x plus 2. And then what we're going to do is we're going to slap it in a square root. My claim is that this is a function. I'm going to call it g of x. And it's a little more complicated than 5x plus 2 because of the square root. Let's look at the graph on a calculator to start. So on the calculator, I want to go to the y equals screen. If you think you might need an equation that you typed and you don't feel like typing it again, you can do what I did before and turn off the equal sign by going on top of it, hitting enter, and unhighlighted equals won't graph. Alternatively, if you hit clear, that just wipes it out. So I don't need these right now. Square root is second square. 5x plus 2, close parentheses, graph. Interesting little function. It looks like it might start here on the axis somewhere, so I might zoom in there to see. So I could hit zoom in, and the zoom in works by picking a point to zoom in on. See that little plus there? I'm going to put that plus somewhere near where it looks like it terminates, and hit enter. Oh look, it actually doesn't zoom in on, it doesn't start on the axis. Here it actually is lower down. So is that the first point of the graph? Here's the problem with the calculator. Notice how blocky that is. The resolution on these TIs just sucks. And so it's not really giving me a good view of what's happening here. So I can estimate the domain and range of looking at this graph. Notice there are no points to the left of whatever that x value is, and there are no points below whatever that is. Okay? So it's got a restricted domain. I want to find out where it starts. To do that, I have to start with looking at the function here. And what I have to note is, think way back to Math 95, that the inside of a square root can't be negative. Oops, negative. Mathematically speaking, that means the inside must be greater than or equal to 0. Right? Not negative means positive or 0. Well, what is my inside? My inside happens to be 5x plus 2. So as long as 5x plus 2 is greater than or equal to 0, I can take the square root. Oops, 0. Weird. Solving that for x, I would subtract 2 from each side. That leaves 5x is greater than or equal to negative 2. And dividing both sides by 5, it's okay to divide by a positive. If you divide by a negative, remember you got to flip-flop that sign, that inequality. I get x is greater than or equal to negative 2/5. Negative 2/5 is also equal to 0.4. Boom, I got the domain. The domain here is negative 0.4 to the right forever. Now, as far as the range goes, according to the graph, there is some special y value, I'm going to write it like that, that is the lowest y value. Right? Look at that graph again. Right? There's some lowest y value. Now the calculator is not exactly estimating it for me. If I hit trace here, and I trace to the left here, I can't quite get to negative 0.4. Notice what happens. Here I'm just to the left of negative 0.4, and if I try to go one more step over, I get no y value. I can't deal with it. So I got to go to my paper and figure it out. So let's see here. If I were to actually plug in that magic y value, right, so I know the range looks something like this. So if I plug in, my magic x value into my function, g of blank equals the square root of 5 times blank plus 2, my magic x value is negative 0.4. That should lead to the magic y value, I hope. And we'll take a look on the calculator. So what do we get here? 0.4 times 5 is 2. It's now negative. So I have the square root of negative 0.4 plus 2. Let's see, 2 minus 0.4 is 1.6. So that gives me, did I do that right? Oh shit, no, that's wrong. 5 times 0.4 is 2, and it's negative. Oh, check it out. Negative 2 plus 2 is 0. Square root of 0 is 0. So I get the point, negative 0.4 for x, 0 for y. That must be the minimum function value. So now I know the range, by looking at the graph, and my calculation must be from 0 to infinity. Now, although the calculator's resolution won't show me that, I can, whoa, glare, put myself in trace mode and type -0.4, enter, and it says, hey, y is 0, even though it's not connecting to that particular point. And again, it's just because of the resolution and the way the calculator graphs. It's not showing me an accurate picture of this function. That happens for some functions, and we'll see those functions more throughout the course. And I think I'm at my 15-minute time limit.